guys. Continuing with our theme of factoring, today we're going to learn how to factor a very specific type of trinomial, and it's called a perfect square trinomial. Now, in yesterday's video, which was the Xbox method, we learned how to factor trinomials. And in our activity today that we were doing on Desmos, we were also factoring trinomials. Trinomials are anything with three terms, and usually it goes in the format of x squared, then a letter x, and then just a number, a constant. So three terms in that descending order is a trinomial. If you're following along on our factoring book, we're working our way up from the bottom. So we did box method on Monday, X box yesterday. And right now we're going to be doing perfect square. Perfect square is on the bottom of our double color. And since it's a trinomial, we wrote the number 3 on this side. Remember, this number determines how many terms the problem needs to have. And then that will tell you which method to use. And then when you're ready, go ahead and open this up. And as you can see, I have 2 of the same color. We're going to do our sample problems up top, and then I'm going to have 10 try on your owns for the bottom part of the paper. Okay, so samples up top, 10 try on your owns on the bottom. And then if you're just using regular lined paper, make sure that you're still writing everything down from the PowerPoint. All right, so perfect square trinomials are special trinomials that when we make that picture rectangle like we were doing in our Desmos activity, it makes a perfect square. It's not a rectangle, it's equal on all sides, so it makes a square. Perfect square trinomials have a very specific type to them, and we can identify them by checking for 2 things. So the first thing we need to check for is, can the first number and the third number, can we take the square root of them? Are they perfect squares? Now, x squared is a perfect square, right? Y squared is a perfect square. But we also want to check for the numbers. So perfect squares are numbers like 1, 4, 9, 16, 25, numbers that we know the square root of. So that would be the first one and also the last one. And the first and last numbers also have to both be positive. So perfect square trinomial will not end the problem with a minus sign. The second thing we need to check for has to do with the middle term, the second number. And it's a math equation. It's a very quick math equation. And it says that the second number, the middle term, should be equal to whatever the square root of the first number is, whatever the square root of the third number is, and those multiplied with the number 2. Now, for the middle term, we don't care if it's positive or negative. That's why I put a plus or minus sign here. If I'm looking at this example, this is a very generic example, I could say, the square root of a squared is a, and the square root of b squared is b. And if I do a times 2 times b, I get the same thing as what was in the middle. So this is how we kind of check for perfect square trinomials. We take the square root of the first term, the square root of the last term. We always multiply by a 2 in the middle. And if we multiply those 3 things together and it matches, then we say this is a perfect square trinomial. Here's an example with some numbers. So here I have a trinomial, 3 terms, x squared minus 12x plus 36. And so the first thing I'm going to check for is, can I take a square root of the first term? And the answer is yes, I can. It's x. Then I ask myself, can I take the square root of the last term? And the answer is yes, I can. The square root of 36 is 6. And the final thing I ask myself is, if I multiply those with the number 2, x times 2 times 6, will I get the middle number? And the answer is yes, I do. Now, again, for the middle number, it can be positive or negative. That doesn't matter. What does matter is that they are both the 12x. So this is the work that you need to do to check and see if something is a perfect square trinomial. So you want to write out the original problem, and then directly underneath it, take the square root of the first number, take the square root of the second number, times it by 2, and check and see if that becomes the middle number. At this point in time, if you're using your factoring book, we're going to jump down here to the bottom. We're going to do 10 problems. And right now, all I want you to do is I want you to copy down the 10 problems, do that little bit of work, square root times 2, and then write the word yes or no next to each question. When you've completed doing that, So write down the problem, a little bit of work, yes or no, for all 10. Come back to the video and we'll check and see how you did. All right, let's check those answers. So on the first one, I hope you got yes. It was x times 2 times 4, which is 8. On the second one, you should have gotten a no. And the reason why you should have gotten a no on the second one is because the last term has to be positive. So the fact that this was a -9 is bad. And so this is not a perfect square trinomial. Now in these problems, we're only checking to see if they're a perfect square trinomial. We're not really checking for anything else. For number 3, it was also no, because x times 2 times 5 does not equal 5x. That middle term did not check out. Number 4 is a yes, because it's actually the same problem as number 3, but it's got that 10 in the middle, which is what we were hoping for. Number 5 is a yes. Number 5 is going to be 2x and a 5. When you times that by 2, you get 20. So we're good on number 5. Number 6 is a no, because I don't know the square root of 12. Now, that doesn't mean we can't factor it. We could potentially factor it using Xbox, but we can't factor it using perfect square trinomial. Number 7 is a yes, even though it's in a weird order. It's 7 times 2 times y, and that does equal 14y. Number 8 is a no. Number 8 is a no because I don't know the square root of 2. And if I factor out a GCF, if I factor out a 2, well, now I don't know the square root of 8. So number 8 is factorable, but it is not a perfect square trinomial. Number 9 is no, because the 3 is negative and I don't know the square root of 3. So lots of reasons why it's not a perfect square trinomial. Again, we can factor it using Xbox from yesterday's video, but it is not a perfect square trinomial. Now, number 10 is a little bit tricky. Number 10 is actually a yes. The square root of 1 is 1, and x times 2 times 1 does equal 2x. So that was a yes. So in total right now, we have 1, 2, 3, 4, 5 yeses and 5 nos. All right, so those were our trying our owns down here. We're going to come back to those in a second. Right now, let's move back up to the top. Because all that we've done so far is identified if something was a perfect square trinomial, but we haven't really actually factored it. We don't have an answer yet. After you're done identifying if something is a perfect square trinomial, it's very easy to find the answer, especially if you showed that little bit of work that I asked you to, that a times 2 times b equals 2ab. If you've decided that something is a perfect square trinomial, to write your answer, you're going to write a parentheses with a square on the outside. And inside the parentheses, you can take that from what is currently written on the paper. I'm going to take the square root of the first term, which is a. I'm going to take the sign from the middle number, which is a plus sign. And I'm going to take my square root of my last term, which is a b. And that's how you determine what goes inside the parentheses. The square root of the first number, the sign from the middle number, and the square root of the last number, and then put it in a parentheses with a square on the outside. And that is how you factor a perfect square trinomial. Now we had another example with numbers. It looked like this. So let's try to write the answer for this one. To write the answer for this one, again, I need a parentheses squared. Inside the parentheses, I'm going to put the x, the minus sign, and the 6. And then I just square it, and that's my final answer. So again, writing this one step of work underneath will be very helpful for you. Let's do one more example from start to finish. So here is my last example problem. Now this problem, we definitely don't want to try Xbox on this from yesterday's video because I would need to multiply 81 times 16, and that number is ginormous. I don't even want to know how big that number is. It is huge. And so when you see a problem like this where the numbers are really, really big and you're like, I don't want an Xbox, check and see if it's a perfect square trinomial. So first we ask ourselves, can I take the square root of the first term, the whole thing? So the square root of 81 is 9, and then the square root of y squared is y, so that's good. Then we jump to the end and we ask ourselves, can I take the square root of 16? And the answer is yes, it's 4. And then it is really important to double check the middle term. Sometimes you can square root the first and last ones, but if the middle term doesn't check out, then it's not a perfect square trinomial. So it is important to do that last step, which is where you put a times 2 in the middle, and it's always a times 2. You multiply that out. 9 times 2 times 4, and this equals 72. So we're good. This is a perfect square trinomial, and I'm ready to write my answer right now. My answer is 9y plus 4 parentheses squared. That's it. To finish up today's notes, what I'd like you to do is I'd like you to go down to the trying your owns down here where you wrote the word yes. And I'd like you to write a final answer because we haven't done that yet. So here are the 5 problems that we wrote a yes on. Numbers 1, 4, 5, 7, and 10. So take a minute right now. If you haven't written down the underneath part yet, write that down because that's where the answer is going to come from. And then when you're ready, we'll check our answers. Okay, hopefully you've written down your 5 answers. The factoring for number 1, it turns into x plus 4 squared. The factoring for number 4 is x plus 5 squared. For number 5, we have a 2x minus 5 squared. Number 7 is 7 minus y squared. Notice that I kept the order that it was in originally. And for the last one, it's x minus 1 squared. So again, this is how you factor a perfect square trinomial. So if you can tell beyond a doubt that something is a perfect square trinomial, then you can get your answer really fast, and it makes things nicer for us. This concludes today's video.